All right, so here we go. So here's the lecture. I'll kind of move through that and get to the homework like usual. So we're going to start. It's pretty simple. You know how we always start with the proportions? You know, like percentages. That's what we'll do tonight, 2 percentages. And then after spring break, we'll do 2 means, like averages, independent, and then something called match pairs. They're both means. We'll see later. So basically, percentages tonight. 2 groups instead of 1 group. Otherwise, it's the same. So, yeah. So, methods for testing a claim made about 2 population proportions and confidence intervals. So, same thing. There it is. Hypothesis test, confidence. So, that's the heartbeat of statistics. We're doing those the rest of the way. So, now there's going to be P1, N1, Q1, X1, and then P2, N2, X2, Q2. It actually isn't much harder. It's just the same thing. You're just doing it twice. All right, here we go. Here's the requirements. I never really pay much attention to those. They're kind of more official. You know, if like you're doing an official study, you would need to worry about those. I'll just leave them. They're in your lecture notes. This is on the Canvas website if you ever need to grab them, print them out if you want anything official. But I'm not going to test you on this stuff, you know. They have to be independent. So to officially use the methods, you got to have, they have to be from random samples. They have to be independent. We'll talk about independence. There has to be at least 5 in each group, successes and failures. Like I said, I'm not going to test you on that, but those are the official requirements that are observed in a real official study. All right, so hypothesis test, like usual. And let's look at an example. That's always where things start to make sense. So, proportions of cars with rear license plates only. Are they the same in Connecticut and New York? Do y'all have a rear license plate on your car? I mean, rear only? Do you have a front one?
Yeah, I got a rear only.
Rear only? Do you ever get ticketed for it?
No, but I've been pulled over a lot though.
I've been figured out 4 years supposed to have
Well, have you? Because I was told because we bought a car a couple of years ago, and it only had a rear license plate.
Yeah, if your vehicle doesn't cover the front, if it doesn't include the front for a license plate, technically you don't need it.
Yeah, it's the law, right? In California, you're supposed to have front, but I heard they never ticket it in California, but maybe I'm wrong. How about?
You can always display it your windshield or your.
Yeah, they give you a ticket, huh?
You know what I told them? The DMV only gave me 1. Which they did. They only gave me 1.
Ooh, were they okay with that?
They were like, you can't do nothing about it. Like, what do you want to do?
Did he write you a ticket? No.
None of them ever done.
Okay.
They always try to use that as an excuse to pull me.
But Val, they wrote you a ticket,
I
huh?
don't want to.
Okay. Anyway, so we're going to compare Connecticut and New York. Contiguous states, they're next to each other. Both having laws, they both have laws like California does that require front and rear. But the proportion of Connecticut illegal cars with rear license plates is this, 11%. The proportion of New York illegal cars with rear license plates only is much lower. Look at that. Why do you think in Connecticut, 11, almost 12% of the cars are technically illegal with rear only, but in New York, it's only 1.6 because New York people are just more law-abiding?
No, they don't have that much cars.
Yeah, they don't have any cars.
They have a lot of bikes.
A lot of bikes.
Taxis.
A lot of taxis, yeah. What's that?
Public transportation taxes.
Yeah. So that would explain why there's less cars. But why is there a lower percentage? Because what?
Because there's less cars.
So would less cars make a less percentage?
Less people drive.
So the difference between percent and amount, are you feeling that? Like I could have a jar of I could say in here, what percentage of us are wearing hats? Looks like 2 people out of, I don't know, what are we, like 15? 2 out of 15 are wearing hats. What's that percentage? Let me see. What it is? 2 out of 15. That could be 30. So 13% of us in here are wearing hats, right? Okay, and then what if I watch a baseball game between the Red Sox and the Giants? And at that game, that would be one of those rare games when American National League play. They do mix it up now a little bit in regular season. Anyway, and what if 10% of the crowd is wearing hats at that baseball game? Does that mean there's less people because there's a lower percentage wearing hats? No, so there's a difference between percentage and amount of people, huh? That just means there's a lower portion of the crowd wearing hats than are wearing hats in here. There's only 10 per 100. Percent means per 100, right? That means 10 per 100. Right, you good with the percent symbol? That's why there's 2 zeros in the percent symbol. That's what it means, huh? Percent. How long is the century? 100 years. So cent means 100. Cent is 1/100th of a dollar, a cent. Right, so whenever we say per cent, we're saying per 100. So if I say 10% of the crowd is wearing hats at the ball game, that means 10 per every 100. If I could break the whole crowd into even groups of 100 and spread out the hat wearers evenly, there'd be 10 per every 100 wearing hats. Whereas in here, there's 2 per 15, which if we were 100 people, that would be 13 per 100. Does that make sense? When we change to a percentage, what percentage means? If we spread out the hat wearers, Eddie and Mario, if we spread out the hat wearers, among 100, there'd be 13. That's the same as 13 per 100. So anyway, so percentage is different than amount of people, is my point in that. You can have a higher percentage, but there's only 2 people wearing hats, but it's 13% of us. So the fact that New York has only 1.6% of their cars are illegal, and Connecticut is much higher. That's not, you can't explain that by just saying Connecticut has more cars. They do, they certainly do. I agree with all that you're saying about New York public transportation, hardly any cars, $1 million to park anywhere, I think, right? But we can't explain percentages by just saying they have more cars or less cars, right? It can go the other way. You can have a higher percentage with a lower amount of people, right? You with me? So Connecticut has a higher percentage of illegal cars than New York. So the question is, do you think that one of those states is not enforcing the front license plate law as strictly as the other state?
Maybe.
Does that make sense? The question, that's what they're supposing in this question. What's making the difference is the police. Which state do you think is enforcing the license plate law more strictly? And New York has much lower lawbreakers. So probably it's being enforced there more strictly, right? In New York, they're probably taking it serious, whereas Connecticut, they're not taking it as serious. That's the supposition. So now the question is, are those significantly different? Those are certainly different. But are they, could that just be luck? Remember, that's always what we're doing in stats, huh? We're saying, yeah, they're different, but could that have just been luck of the draw? You know, we got 239 out of 2049, 9 out of 550 came out different. But could that have just been luck of the draw? Or are those different? Bless you. Those different enough that we believe, no, there's strong evidence that what's happening in New York is much more enforcement of the law, so people are really having both license plates, whereas in Connecticut they're not. What do you think? So that's what statistics does, right? It comes in and it says, is this significant? Is this beyond luck? Is this not reasonable to think it's just luck anymore? That's the question. All right, how do we do that? Well, here's the numbers. So cars with rear license plates only, 239 in Connecticut, 9 in New York, out of 8 with front and rear, out of 2049 total, 9 out of 550 total. There's how they got the percentages in the various states. So they want me to test this. They want me to compare 2 groups. So see how we're doing 2 groups now? We're talking about 2 percentages. And we're saying, are these significantly different? Or are they close enough that, hey, they're basically the same? And you know, what if one of them came out to be like 11.7% and the other came out like 10.9?
Pretty close.
Yeah, we would think, those are basically the same. Yeah, they came out a little different, but that was probably just luck of the draw. They're so close. Probably the same stuff's going on in both states, huh? We would conclude that. But if the percentages come out way different, and of course we still need to do the stats, We want to test and see if there's a significant difference beyond a reasonable chance of luck. That's always what we're doing. So that's the deal. We want to compare the two percentages. They look, to me, off the top, very different. Right? This one's only 1.6%. That one's 11.7%. They look really different. Okay, let's take a look. So are they different? So first off, you got to do the claim. What's the claim? The claim is that Connecticut and New York have the same proportion of cars with rear license plates. No, wait a minute. How are we claiming that? I thought we just saw that they don't. That would be a great question. Are you with me? Am I losing you? How are we doing? It's getting too wordy. So step one, here's the claim. Connecticut and New York have the same percentage of cars with rear license plates only. Is that true? What would you say to somebody that said, what are you doing? This statistic stuff is dumb. That's a dumb question. We just saw that they don't. End of story, didn't we? Didn't we just see back here? They don't. 11.7%, 1.6%, they don't have the same percentage. The answer is no, we don't need a bunch of fancy stats. No, done. Dumb question. No, that person's wrong that's talking that way. There's something they don't understand. What don't they understand? Why do we need to do all those stats? Why isn't that just, they're different, end of story. Maybe I need to ask it. All you guys are like, I don't know. This isn't the first time I've asked this kind of question, but maybe I need to keep asking it more and more and more, just to make sure we're getting. Because I don't want you to miss the force. We do so much, button pushing and moving things around, we can forget the big picture. Okay, so why? What was one of them? 11.7, 1.6. So Connecticut came out 11.7. New York came out 1.6. But remember that was just from a sample of a few. We don't know that that's the real story for all the cars in New York and all the cars in Connecticut. Remember? That's what we're always doing in stats. You always take a sample, but you don't know if that was just a lucky sample. So the problem is, and what I would say back to that person who talked that way, is I would say, well, how do you know that wasn't just a luck? This 11.7%, this isn't 11.7% of all the cars in Connecticut. No. Were you thinking that? No. That wasn't all the cars. That was just the whatever 2,000 in the sample. And this 1.6%, that wasn't for all the cars in New York. That was just from a sample of 550, I think, or whatever. So how do we know these weren't just lucky samples? And really, New York and Connecticut, when you do all the cars, are really the same. How do we know? Well, statistics will come in and tell us what the chances of that are. And if they're crazy low, then we'll say, no. That is strong evidence. We believe they're different. Or maybe we'll say, no, evidence is not strong. We don't know. Make sense? That's why we're always doing stats, right? Because we always just have a sample. It's just like before the last election, right? Didn't the polls show that, weren't most of the pollsters surprised? Didn't they think it was going to go Democrat, the election? I mean, it was close. Most people were saying it was going to be close. But anyway, so same kind of thing, right? Polls don't always know. Samples don't always know. When the real thing hits, then you know. So that's kind of like what's going on here, right? Samples aren't always for sure, are they? These are just samples. The statistics will tell us what the chance of luck is. That's the p-value, right? The p-value is the percent chance of luck. So if that's really low, then we think, hey, it's probably not luck. I mean, it could always be luck, but at some point you're like, no way. That's just not luck. That's such strong evidence. There's just no way. All right, so that's what we're doing. So you know the deal, right? What do we always do for HO? Equals. So now we have two P's, but it still equals. HO is going to do the same thing it always did. It'll be equals always, but this time instead of just one P, there's two proportions. And the H1 being the opposite, it's not equals. Okay? And which one's the claim? Which one of these two is the claim?
Same proportion.
Here's the claim right here, that they're the same.
HO?
HO is the claim. We good?
I said valid.
we gotta do the calculating. Yeah, we gotta see if it's right or not. All right, so then 0.05, like usual, significance level, do the calculator, blah, blah, blah. There's the answer, but I haven't shown you anything. So how do we do this on the calculator? All right, so here's the part you've been waiting for. So let's do this on the calculator. So what do? We hit our stat button, of course. Hey, can you guess? Go over to tests, of course. Can you look down and figure out which test? I bet you can figure it out. Look at your calculator. Give everybody a chance.
2 prop Z test?
Yep, two prop Z test. So the two proportions Z test. Yeah, because we have two proportions. Now we'll do the two sample after Easter break because that'll be two means. So that'll be later. That'll be section 9.2, the next section. Yeah, so just do the two prop Z test. Hit the buttons. Okay, and then it's going to ask you for x1 in 1, x2 in 2. You seeing all that? x1 in 1, x2 in 2. And, okay, so what do you think x1 is here? Oh, the numbers are off the screen now, aren't they? Let me go back here. Where are they? There they are. All right, there's all of our numbers here. I'll put it right here. So x1 in 1. What do you think is x1 and in 1?
239 and 2049.
Yeah, exactly. 239 and the 24. Now, we skipped the 1810 there, huh? So we just want to know the number of cars that are rear license plates only, and info is the total, huh? On everything in stats, right? And then, so put that in, and then x2 into 9 in the 550, exactly. Let's put those in. And that's a, what was this? This is not equals one, huh?
Yeah.
Not equals. And then we calculate. Did you hit the buttons? All right, so if you got that down, I'll go to the, well, I'll just write it right here. I got Z, did you get a Z number that's 7.107? And then the P, I got 1.19, blah, 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 blah. And then that E thing, E minus 12. Remember that means? That means basically 0, huh? Because that minus 12 means the decimal goes back 12 places. Take this decimal, run it back 12 places. So that's 11 zeros, right? So that's basically 0. So P is 0. Now, what does that mean?
That means HO must go.
Yeah, the null is very low, right? So I'll move it over if you got that down. So here, yeah. So they're telling the p-value is 0. The z is 7.11. That's what we got, right? Yeah. Yeah, if you rounded it, 7.11. Okay. So, and then what does that mean? Because the p-value is low, we reject the null. Just like Val said, right? And what was the null? HO, let me write them again. It was equals, P1 equals P2. P1 does not equal P2. So we reject the null. We keep H1. Is evidence strong or weak?
Strong.
It's always strong when you're keeping H1, huh? And which one was the claim? HO was the claim. They claimed they were equal. We reject that. So there's strong evidence. I was listening to a book on tape on the drive out here today, and he talked about hypothesis tests. I didn't expect him to. It was some totally different thing. But anyway, it was a science thing. But anyway, he said null hypothesis. He said it the way I had never. He said the null is the thing you're trying to nullify. I never thought about it that way. So anyway, and we did. We're nullifying the null. Right? To nullify it means to get rid of it, right? And that's exactly what we did here. That's generally what you're trying to do. Same thing in a court of law, right? You bring in the person under a criminal court because you're trying to prove they're guilty. You wouldn't have them there if you didn't think there was some evidence that they were guilty. Same kind of thing. You're trying to get rid of the null. I never thought about why it's named that way. You nullify the null. That's right. All right, anyway, so our conclusion is they are not equal. Like we said, those are super different percentages. There is strong statistical evidence that New York and Connecticut must have very different amounts of cars that are obeying the law, because that couldn't just have been luck. I mean, there's always a chance of luck, but it's almost nothing. It would have been amazing to get those kind of numbers by luck. Better than winning the lottery 3 days in a row. More unlikely. That's what I mean by better. All right, so here we go. So what does that all mean? We reject the null. We conclude there's sufficient evidence, strong evidence, to warrant rejection of the claim. There is sufficient evidence to conclude that Connecticut and New York have different proportions of cars. Like we said, they're different. They're not the same. It's reasonable to speculate that enforcement of the license plates laws is much stricter in New York than in Connecticut. All right. Now, last thing. Oh, yeah, this is probably the main concept. That's not much new, is it? That's really similar to what we've already done. Here's the one thing. Let's do a confidence interval for the same data now. So your calculators are nice. I noticed, this was news to me, that if you change over to confidence interval right now, it'll grab the same data you just put in. You don't even have to redo it. So where do you find it? So go to stats. We're going to do a confidence interval for the same problem. Hit stat and go over to test. Can you figure out which one is the confidence interval for this? Remember, we want an interval, not a test. Now we're doing an interval, not a test. We just did the test. We just did the hypothesis test. Now we're doing a confidence interval. So, do you see it down there? What is it?
2 sample 10.
Not sample. We have, that'll be next time.
Is it two props?
We're still doing prop. These are still proportions, huh?
Two props the interval?
2 prop Z interval.
Number
B, way down on B, at least on my calculator, probably yours too. 2 prop Z interval, right? Because it's 2 proportions. These are percentages, right? And it's a Z interval. It's an interval, not a test. Yeah, 2 prop Z interval. So if you hit that, it's already got the numbers in there. Do you see that? If you did the last one anyway, it'll automatically have the numbers in that you just put in last time. Isn't that nice? And then they want us to do a 95% confidence interval, so you have to change it. That's the only number you'll have to mess with. Make it a 95% confidence interval. Hit the button, and I'm getting 0.0828, 0.11776. Did you get that?
Yep.
Okay. Now, this is, they are going to push us one place in this chapter 9. So I don't think you're going to have any trouble with all this. This is all the same stuff. Just type it in, hit the buttons, boom, boom. You've got it. But what will be new is this concept. So let's spend our time getting this straight. They're gonna help us to more exactly understand the relationship between a confidence interval and a hypothesis test and how they relate to one another. They're really two sides of the same coin. What do we mean? This is a confidence interval for what? For the difference. Remember, remember what we were doing here. This is, or I should say right here, the difference between the two populations. So in other words, this is P1 minus P2. That's what this is. This is P1 minus P2. All right, so let me do this for you. Let me help you for a minute. I need some space here. Let me just get some space. Yeah, good. There's some white space. Think about this with me, guys. What if I say, hey, I'm thinking of a number, okay? 10 and the other number's 8. What's the difference between those numbers? It's going to be 2, right? So what if I said, and this one, let's just call this one, P1 and this one P2. Okay, if I said, hey, P1 minus P2, the difference, is 2. That means these numbers are different from each other by 2. If I told you the difference is 0, what would that mean about those numbers? They're the same number. If the difference between two numbers is 0, they'd have to be like both 8 or both 10 or something, wouldn't they? To have a difference of 0, right? So it's all, when you do a confidence interval, it's all about whether 0 ends up in that interval or not. What am I talking about? Because if the difference between two numbers is 0, let me write that out. When P1 minus P2 equals 0, when the difference is 0, the numbers are the same, aren't they? If two numbers have no difference, then they are the same. Right? Two numbers are not different. So, okay, so what? Well, that has to do with our confidence interval. So go back to our confidence. Here's our confidence interval. We are 95% sure. 95%, we're very sure that the difference, P1 minus P2, that's what this is. This is a confidence interval for the difference, is somewhere between 0.08, 8%, and 11%, or 12, or whatever. Is 0 in that interval? Is 0 between 8 and 11? 0 is not between. So what? Well, that means we are very sure that the difference is not 0. How are we doing? Am I making any sense? I'm feeling like I'm doing the Charlie Brown teacher voice up here. The wah, 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 wah. You see the Charlie Brown? How are we doing? Am I making any sense? The wah, wah, wah. So, when you do your confidence interval, it's all about, is there, now you think, well, how can 0 be in there? Well, if this was negative. Say that was negative. Yeah, if you have a negative number and a positive number, then 0's in between, huh? But if you have two positive numbers or two negative, either way, then 0's not between. The only way 0's between is if you have a negative and a positive in your confidence interval. So basically, if you have two positive numbers, then 0 is not between. Okay, so what? Well, that means you are very sure, 95% confident, that 0's not in there. Okay? And what does that mean when 0's not in there? That they're not the same. Because remember, if their difference is, remember this is the difference, if their difference is 0, they're the same. As we talked about. If two numbers have no difference, then they're the same number. Well, we are 95% sure that their difference is not 0. So we are 95% sure that they are not the same. Do you see what that confidence interval is saying? It's telling us the same thing the hypothesis test told us. They always do. They fit hand in glove. It's telling us you're 95% sure that these two states are not the same. Why? Because the difference is not 0. You're 95% sure that the difference is between 0.08 and 0.11, not including 0. So we're 95% sure the difference is not 0, so they are not the same. That's our conclusion. That's what they're saying here. Does not contain 0, suggesting that there is a significant difference. If the difference is 0, they're the same. 0 is not in there. So the confidence interval suggests that P1 is greater than P2, and evidence to reject the claim. Same thing. Confidence interval is telling you the same story. All right, that's the lecture. Here we go. So here's the homework. Let's go through the homework. So question number 1, a newspaper published an article about a study in which researchers subjected laboratory gloves to stress. So you nursing people, this would be a good one. Among 222 vinyl gloves, 57% leaked viruses. Ouch. That's not good. Among 222 latex gloves, 7%. What do they use in hospitals? Do they? Do they use latex?
Not latex anymore,
Not
because
latex
allergies, so it's vinyl.
But they go to vinyl?
Yeah.
Because latex cause problems with skin.
It's allergies, yeah.
What does it do? Allergies?
Yeah, latex, so they got rid of latex because allergies, a lot of people have allergies,
Ah.
and so they just shipped over to vinyl.
Okay, so now there's a study saying, hey, maybe vinyl, though, leaks through more. That's what that study's examining. I don't know if that's true. You go on Google and find out. Maybe they might just be making this up. I don't know. But anyway, I'm sure this is the kind of studies people do, right? And you can see the value of it, right? We got to find out, do they leak more? If so, that's a problem. Maybe this is just a lucky group, though, right? That's always the issue. How do we know if it's just luck or if it really means something, right? Because you'd want to know if you're using them all the time and you're around stuff you don't want leaking onto your skin. So, okay. So here we go. So we're going to test what's the claim? So let's start off with just like usual. Let's write the claim. We always start with the claim. What is the claim? Test the claim that vinyl gloves have a greater virus leak than latex. Vinyl greater than latex. Okay. Vinyl is right here. Looks like that's the first one, P1. And latex came next, so that's P2. So they're saying vinyl greater, right? Vinyl greater. So P1 greater than P2. That's what they're saying. Are we good so far? So how'd I get that? P1 is vinyl just because they put it first, you know. And P2 is latex, so they put it second. And they're saying the claim is vinyl greater than latex. P1 greater than P2. All right, let's write H0. Let's write H1. What is H0 always? Equal. And so what am I going to put for H1? Since I've got this, that'll be H1, won't it? Right? I'm not going to write not equals. You only write not equals if you don't have a greater or less somewhere already. We have a greater. That's my H1. Just like in the last chapter. Good? We just have two populations now instead of one. All right, let's go through it. So which one, A, B, C, D, E, or F? Which one is right? D? Oh yeah, D. There it is. You're right. D it is. All right, can you put this stuff in your calculator? We need the numbers, don't we? What are the numbers?
It shows it in that box.
What box?
Scroll down. Technology results.
Oh, thank you. So in the calculator, let me erase some of this stuff.
7%, which is 127.
Yeah. So for P1, it said 57% of 222.
Are these the two prop Z test or the prop Z?
2 prop Z test. Yeah. P2, it's 7% of 220. Both cases they had 222, huh?
Oh, those would you round up?
Yeah, so not round up. That's only for sample size that we do. We're going to round off. Yeah. So let's take our other point. 57 times 222. I'm getting 126.5. So to round to 127. And 0.07 times 222. I'm getting 16. So y'all okay with what I did there? I just found the actual numbers. We need the actual numbers, don't we? 57, of means times, doesn't it? In math, of always means times. So 57% of 222 means 0.57 times 222, got 127. Actual gloves, whatever this is, that the vinyl? That's the vinyl. So among the vinyl gloves, and this group down here is the latex. So in the vinyl gloves, 127 out of 222, that's a lot. It's more than half leaked. And for the latex, only 16 out of 222 leaked. So put that in your calculator. So we're going to have X1. So we're going to have, 127 is your X1. This is your N1. This is our X2, N2, right? So stat, 2 prop Z test. And we're doing a greater than test. And we calculate. So I got a test statistic Z equals 11.27, round to 2 places. Did y'all get that?
Mm-hmm.
And the p-value? Oh, it's going to be 0 because it's not. I got 9.09 with an E minus 30, so it's going to be 0 on that. I'm going to probably remove that question. Sorry. I'm going to probably just yank. I don't like the way they do these questions. They do them with something different. I don't know why I didn't notice that when I picked the homework. But anyway, so let's finish it up though. But I'm probably going to yank this one from the thing. Yeah, don't worry about number 1. Yeah, I can't change it now that you've started the homework. It won't let me yank it. So don't worry about number 1. They're saying this is 11.40. They do it I don't know what they do. They do something different when they have these percentages. I'm not sure what they do. Eddie.
It's like, on my calculator, like, I do it on the calculator, on this it's supposed to be like a 14.28, but on my calculator it's like a 15.45 or something like that.
For this problem?
Well, not that one, but this problem, but with my numbers.
Mine just says quit.
So Eddie, are you talking to me about this problem or a different problem?
No, it's this problem, but with my numbers though.
Oh, your numbers are different. Yeah.
Yeah, because like the numbers they give here for like whenever you put up that little window, it's like 14.28.
Uh huh.
And I calculated it with my numbers, with the numbers here, you make a 15.45
They're off
for the
yeah.
Z.
What you're
Yeah.
saying is this is off too.
Yeah.
Yeah.
Gotcha. Yeah, I'm not sure what they do on the percentage. But let's don't worry about that. Let's just move on with the rest of the question. Same p-value, and then what's our conclusion on this matter?
Did you put the props in
The null must go.
Yeah, null must go. Cross out the null.
proportion 1, proportion 2?
And what was the claim? I never even.
That it was.
Oh yeah, here it is. Or where is it? Did I write it?
So mine's like
So P1 is greater than P2.
Oh yeah, I just erased it, huh? Yeah, that was the claim. So that's strong evidence, right?
5%.
There's sufficient.
Yeah. So what is the conclusion? The p-value is.
Yeah. Can't put that.
Well, I don't even know what numbers they. So yeah, so the p-value is less than the significance level, right? The p-value is really low.
Still says quit.
Let me see.
So what are we gonna do? We're gonna reject the null, huh? Reject the null. There is sufficient or strong, sufficient evidence to support the claim that vinyl gloves have a greater leakage. Wonder if that's true. All right, or if they just made up these numbers.
Mine's we use something else for my word. It's like poly something.
Polyurethane or.
Nitro.
We were not supposed to have used our calculator on that one. We're supposed to just look down to the bottom, grab the Z, grab the P, go back up. You're supposed to just grab the one they gave you. I don't know exactly why their Z came out slightly different than ours, but just grab theirs and you can draw the conclusion. Yes, that's what it is. All right.
Still the same.
Sorry. Yeah, same conclusion. All the conclusions are the same. Just they had a little bit different, and the P is exactly the same. Just a little different Z value, barely. I'm not sure what technology they used, but it came out slightly different. All right, that good? Yeah, number 1, they just give it to you. They just give you the box, like y'all said. I didn't pay attention. Yeah, they give you the they give you the answers. So, all right, good. Let's move on. That's better, sorta. All right, here we go. Test the given claim. Identify the null. Blah 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 blah. Test statistic. Blah blah blah. Okay, among 2078 passenger cars in a particular region, 222 had only rear lights. Oh, same kind of thing. 350 commercial trucks. We're comparing cars to trucks now. 49 had only rear license plates. Reasonable hypothesis that commercial truck owners violate laws requiring front license plates at a higher rate than car owners. Use point 10 signals element to test the claim. Okay. So basically they're just wanting us to do this one. I guess it's just a normal one. So, all right. So let's write out the claim.
P1 is greater than P2.
Yeah. What is the claim? Yeah, I think you're right. Isn't that it?
A higher rate than owners.
All of a sudden I can't find the words. Yeah, I know it said that somewhere.
On the fourth line.
All right. I just can't find the word claim. Do you see the word claim?
A reasonable hypothesis.
Okay, I guess we're going with that, yeah. Is the commercial truck owners violate laws at a higher rate? Yeah. So the claim is, so if P1 is P1 the cars or the trucks? What'd they start with?
P1
They started with cars.
Oh, first?
So you actually could do it either way. Well, no, actually, we better stick with their order.
Mr. Aaron, I'm going to take off.
Sure. So population 1 is the cars. Yeah, I should have looked down there in the words. P1 is the cars, P2 is the trucks. So P1 is the cars, P2 is the trucks.
So it would be less than,
Yeah, right on. So they're saying the P1 is less than P2, aren't they?
right.
That the cars violate less than the trucks. You guys tracking with me? Does this make sense? P1's less than P2? That's what they're saying. So they're saying the trucks do it violate the law more, so the cars are less. P1's less than P2. All right, let's write the HO. Let's write the H1. You know how to do it, right? What's HO always? Equal. And so then this claim must be H1, and I'll write claim right next to it. Now this time we do have to do our calculator, right?
Yeah.
Okay, thanks. They're not giving us the numbers. All right, so take your calculator, crank them out. Now we got to know we're going to do the two prop Z test, and we got to have x1 in 1 and x2 in 2. So can you grab those numbers? It looks like 2078 passenger cars. 222 had rear license plates
Is that,
only.
are you supposed to, so X1 would be P1, right?
Oh yeah, sorry, that's supposed to be P1, not X1, huh? Yeah, you're right. Just using the wrong letters. And then,
Well, what I'm saying is, yeah,
oh, we don't need to add them, because that's the total. 2078 passenger cars. That's the total. That's the N.
well, that'll be on the twos. Or does it matter which one you put in?
They told me to put cars in P1.
Okay,
So that is cars.
okay.
And then trucks come next. 359 trucks. And 49 only had rear license plates. Does this make sense? So you just plug them in like that? Same kind of thing as usual. To prop Z. And we're doing a less than test. Calculate it. I got P. Well, first off, it wants the test statistics. So I got Z. What is it? Negative 1.65? Did y'all get that okay? And then the p-value, I got, it wants 3 places. 0.049. That's the p-value. So what was the test level?
0.10.
Yeah, right, 0.10. So that's less than 0.10. So that p is low. HO must go. Cross out HO, keep H1, the claim. P1 less than P2. Strong or weak?
Strong.
That's strong. Strong evidence, the P1's less than P2. The cars is lower than the trucks, or you could say the trucks are higher than the cars. Same truth either way, huh? That good? Want me to go on to the script? Right, thanks. Okay, yeah, let's do the, didn't we reject the null? What did we do? We rejected the null, and we had strong evidence, huh? So reject the null, reject, it's one of those two. There is sufficient evidence, there's not. No, it's A. That's all you need to read, huh? Just reject the null, sufficient evidence. That's got to be it. I don't even care about the rest of what they say. All right, now B says do the confidence interval limits for the appropriate confidence interval. Okay, that I need to show you. You're going to have to double it this time. But let me give you that table that'll make it nice and easy for you to do every time, and then I'll try to reason with you about why that's true as well. Why I didn't write it down? I thought I did. Anyway, all right. So how does that work? So here we go. Let me do this. So if So hypothesis test. Here's the relationship. Hypothesis test oh, wait a minute. Oh, wait, no, that was right. Sorry, y'all. Hypothesis test. If your test is greater than or less than, if H1 is greater than or less than, then when you do your confidence interval, you have to double the percent, well, let me go 1 minus double the percent. Whereas, if H1 is a not equals kind, then that's 1 minus the percent, not doubled. Let me give you an example. So there's the rule. That'll always work. Let me give you an example of what I'm talking about. So if your H1 is greater than, less than, whatever, either one of those two, say you did a hypothesis test at the 0.05. That's what we usually do, right? 5% significance level. Your confidence interval would be 1 minus double that. Which would be 1 minus 0.10, which would be 90% confidence interval. Are you tracking with me? A 5% hypothesis test would go with a 90% confidence interval. That would be the appropriate one. That's what they mean by do the appropriate one. It's the one that will give you the same answer. Versus if your H1 was not equals and 5%, then you would take 1 minus the 0.05, it would come out 0.95, not doubled. Everybody see that difference? You want to write that down? Now, everybody get that written down? Okay, so now why? I don't want to just leave it like it's magic and we just, right? You guys want to understand, right? Yeah, Ken. Oh, sure. So why is this the case? Well, a 5%, what does a confidence interval mean? If you say we're 90% confident of something and it's a greater than, less than, what you're saying is a greater than, less than is a one. They call this a one-tailed or one-sided. Whereas a not equals is two-tailed or two-sided. I haven't been using those words. I just didn't want to bomb you with too much verbiage early on. But now that you're getting more comfortable with confidence intervals and hypothesis tests, let me give you more of the rest of the story so that you really have a full statistics course knowledge. So a greater than, less than test is called a one-tailed test because there's just one side. There's just one side. It's either greater or it's less. Right? Well, what do I mean? Let me make sense out of that. If I say, hey, X is greater than Y. Well, that means that X is bigger. X could be something like 7 and that could be 3 or whatever. There's just one way that can go. Y can't be bigger. Whereas if I say X is not equal to Y, that could go two ways, huh? X could be the bigger one or Y could be the bigger one, huh? That's what we mean by two-tailed. Are you tracking with me? And this is one-tailed. This has to go bigger that way. This could go bigger that way or that way. Couldn't it? Not equals can go either way. Not equals has two tails to it. Whereas greater than or less than only goes one way. It's a one-tailed test. So what? Well, when we do confidence intervals, if I say a 90% confidence interval, and we're talking greater. I'm 90% confident that X is greater than Y. 90% confidence that X is greater than Y. How does that compare? A confidence interval is always two-tailed. You're always saying the region of your confidence. So a confidence interval is always a two-tailed piece of information. Because you're saying, like if you were saying the difference between X and Y, you're saying that I'm 90% confident that the difference between X and Y is somewhere between 1 and 5, for example. X is bigger than Y by some amount between 1 and 5. Let's suppose 1 to 5 is your 90% confidence interval. That means you're 90% confident that the difference between X and Y is somewhere between 1 and 5. So that means X is bigger than Y by somewhere between 1 and 5. So that leaves out two sides. Numbers bigger than 5, numbers smaller than 1. So a confidence interval is automatically two-tailed. So what that means is, if your original H1 is two-tailed, just do it straight. No doubling needed. But if your original H1 is greater than or less than, you're going to have to double it when you do the confidence interval. That probably wasn't the best explanation. Let's leave it for now. I'll think over Easter break how to say it better. But for now, let's just get the rule, make sure we can crank it out and get through the homework. I probably better not say any more. I'm not saying it. I don't feel like I'm saying it very clearly. Probably, you know what that usually means? When you're not, I've noticed it myself, when I'm not saying something very clearly, it means I don't really get it as clearly as I could get it. You know that old saying how people say, I really know it, I just can't say it? At least for me, that's not true. When I can't say it well, it's because I'm really not thinking it exactly clearly. Anyway, so I know I need to think about it a little more clearly to be able to say that a little bit better. So let's just move on with cranking it out. They want me to do a confidence interval. So let's use that rule. So the question is, was H1 like greater less, or was H1 not equal? Which one was it? I don't even remember now. Oh, it was greater less. We're still on number 2. Sorry, it's been a long number 2. We're still on number 2. It was a greater than less than. So what does that mean? Does that mean I'm going to double it or not double it?
Double it.
Yeah, it means you're going to double it. So you're going to take 1 minus double the percent for the confidence interval. So 1 minus, and what was the percent? 10%. 10% significance level. So 1 minus double the 10%. So 1 minus 20, 80% confidence interval. So on your calculator, do an 80% confidence interval. That's what the appropriate, that's going to give you the same results as the one-sided 10% test. Let me say that again. We just did a one-sided, right, a greater than, or it was less than actually, a less than 10% test. That's going to be the same as a double it 80% confidence interval. 1 minus double it. 80%. So now, take your calculator. Let's find these numbers. Just go right over to keep the same numbers. It'll move the numbers over automatically for you. It's very nice. Go over to the test. Go down to the, whatever it is, the 2 prop z interval. That's where it is, right? 2 prop z interval. 2 prop z interval. It should have all the same numbers, the 222, the 2078, the 49, the 359 already in there, but you need to change the confidence level to 0.8. And then calculate. I'm getting, it wants 4 places, okay. 0.1068 to 0.1365. But anyway, yeah, you guys are right. There it is. It's working for me now. Negative 0.0544 to negative 0.0049. Is that what you got?
Well, I'm gonna do mine.
With your numbers, yeah. Is that okay on this one?
Close to that.
Yeah, right. So, okay, so now, what does that mean? Remember what you want to ask? Is 0 in there? Is 0 in that interval? No. Those are 2 negative numbers, aren't they? So 0 is not in between there. So what does that mean? So let me come out here. 0 not in the confidence interval. So that means we don't think the difference, we don't think P1 minus P2 is 0. It's not equal to 0, in fact. How about that? P1 minus P2, remember, that's a confidence interval for the difference. That's P1 minus P2. You're always doing the confidence interval for the difference. So the difference is not 0. 0 is not in there. So what does that mean then? If P1 minus P2, if the difference is not 0, then they're not equal. You could just add the P2 to the other side. Do y'all see that? That means we are confident they're not equal. If their difference is not 0, see, if their difference was 0, they'd be equal, wouldn't they? If you subtract two things and you get 0, that means they're equal, huh? Right? How else can you subtract two numbers and get 0? They got to be equal, don't they? So if we're subtracting them and we're saying it's not 0, 0 is not in there, then just add the P2 over. That means they're not equal. If their difference is not 0, then they are not equal. That's what we're confident of. So that's what they're going to ask you down here. They're going to say, because the confidence interval limits do not include, does it not include, what are they? Yeah, so they're saying, yeah, so the confidence interval, these numbers, are both less than 0, aren't they? That's their options, less than or greater than. Both those numbers are less than 0. Is there a significant difference? Yes. There appears. Well, back here. I looked at the wrong spot. It's not less than, it's include or not include. So does the confidence interval include 0 or not include 0? Not include. That's what we said, right? Two negative numbers, no 0 in between. There is sufficient or is there a significant difference between the two proportions? Yeah, they're not equal. There's sufficient evidence. Is that all right? Take 3. So it does not include, and I kept thinking sufficient evidence. That doesn't read right. So there is a significant difference. There is sufficient evidence that they're different, right? You knew that all along. You're just waiting for me. All right. Yeah, right? Because 0 is not included. 0 is not in there. Then their difference is not 0. They are not the same. There is a significant difference. There is sufficient evidence to support the claim that they're different. All right. Since an instant replay system for tennis was introduced at a major tournament, men challenged 1393 referee calls with the result that 422 of the calls were overturned. Women challenged 752 referee calls and 215 of the calls were overturned. Use a .05 students level to test the claim that men and women have equal success in challenging calls. So equal success in challenging calls. So can you write the claim? Let's get this problem done. I know you guys are thinking we'd like to go home and do other things with our life. So let's finish this up. So what's the claim? The claim that men and women have equal success in challenging calls. So P1 equals P2, right? Equal success. That the percentage of time they're right in the call is equal. P1, P2. Good? So that's the claim. So HO, H1. HO is always the equal. So then what's H1 going to be? Not equal, huh? That good? Because we don't have greater than or less than anywhere, do we? And which one's the claim, HO or H1? HO's the claim. Claiming the men and women same success in challenging calls. Okay, so here we go. What are the numbers? So for the P1 is, did the men come first or the women? Men, okay. So the men and 1393 referee calls, 422 were overturned. So X1 is 422 out of N1 1393. And then X2 and N2 are the women. 215 of the calls were overturned out of 752 refereed. Hey, I predicted that. You know who the... All right, anyway. So there's the men, there's the women. Let's crank the numbers out here. So we put them into our calculator. This is a 2-prop Z. I got Z. Tell me if I messed up this time. 0.82. Yep. Good. And the p-value 0.4099. It looks like. Oh, 3 places. So I guess we have to round that to 4.410. Yeah. Now they keep changing their minds. Sometimes they say 3, sometimes they say 4. 3 places. 0.410. Okay. So what does that mean then about the conclusion?
Keep HO.
Yeah, that P is not low, huh? The P is not low, so the HO does not go away, does it? The P is not low, the HO does not go. We keep the HO. Is that strong or weak? Weak. It's always weak evidence when you start with the one you're trying to nullify, the null hypothesis. All right, the p-value is, what word do they want there? Oh, is it above or below the significance level? What was it? What's the significance level on this one?
0.05.
Oh yeah, there it is, 0.05. So 0.05. So that's greater than 0.05, isn't it? That's 41%. That's certainly higher than 5%. That means there's a 41% chance that the difference, because they did come out different, but there's a 41% chance that difference, because somebody, again, I hope you're getting the big picture. If you divide these, they are different. You know what I mean? If you take 422, here, let me just divide it real quick. I hope the big picture is not escaping you. If you take 422 divided by 1393 for the men, 422 divided by 1393. For the men are coming off with 30%. They are right in their challenge 30% of the time. The women, if you take 215 over 752, it's going to be different. It's 29% of the time. They're right in their calls 29%. Look at that. Men are right more than women. Sorry, I just couldn't resist. So the men are right in 30% of their referee call when they challenge the call. Women are right 29% of the time. So now they're different, right? Yeah, but not very different. I mean, that could just be luck. Where you just got a few more women than men, or men than women, I guess. That's so close. That difference could just be luck. It really could be. In fact, that's what we determined. The p-value, the percentage chance it's just luck, came out 41% chance. So there's a good chance. We just happen to get a luckier draw with the men, just a few more that got it right than women. Now, it could be real, but there's certainly not strong evidence that the men are really doing better than the women. This is not strong evidence. There's a 41% chance this is just luck. So we do not believe the evidence is strong. It's weak. We stay with the original assumption that the men and women are about the same at this. Even though they came out slightly different, it's not strong evidence. 41% chance it's just luck. That's what that means. Okay, so the p-value is, what is it, higher? Well, I don't even know what we're doing. Higher, greater, whatever they want there. Greater than so what do? We keep. We failed to reject, right? Fail to reject. The null. There's not sufficient evidence to warrant rejection of the claim that men and women have equal success. So we keep it. We say they're pretty much equal. Even though they came out slightly different, too big of a chance of luck. All right, now for the confidence interval. Now, can you do the confidence interval real quick? So use the rule. That's the main part I want to show you. So do the confidence interval. So the main thing is use that rule I gave you to figure out whether you should take 1 minus double the percent or just 1 minus percent. And the percentage we're talking about is the significance level. Maybe I should have just written that. So 1 minus double it or not double it?
Not double it.
Yeah, not double it because this is a not equals, huh? So not equals, don't double it. How about that? So for the confidence interval, we're going to take 1 minus 0.05, not doubled. So 95% confidence interval, huh? Will give us the same results as this hypothesis test of 5% that was not equal. So do a confidence interval at 95%, stat, and go on over to 2 prop z interval, and keep all the numbers the same. Make this 0.95. Calculate it. I'm getting, hopefully the right answer this time, minus 0.0233 to 0.05735. Did y'all get that? Oh, good. I did it right. Makes sense. So 1 minus no doubling. Okay, so then over here, so we write that in again. It was negative, they want 3 places, 0.023 to positive 0.057. So now, what is the conclusion? Because the confidence interval, does it contain 0 or not contain 0?
Yes.
Yeah, 0's in there. This goes from a negative to a positive, doesn't it? So this time 0's in the interval. That's new. So the interval, it contains or includes, I don't know what word they want there, one of those words. Includes, okay, whatever. I've always got the wrong word. Includes. Okay, because it includes the 0, there,
What's the word, go up a little bit?
yeah, what are the words? Yeah, pull it up there. Okay, so what was it again? It was negative 0.023 to positive 0.057. So negative to positive, 0 is in there. 0, it includes 0. And what is number 2? Number 5, I mean? Does or does not? Does appear to be a significant difference. Oh, no, does not. Does not appear to be a significant difference. Because 0's in there, which means they could be the same. Right? If their difference is 0, they're the same. And 0's a possibility. 0's in our interval. Does that make sense? When 0 is in there, then you're saying the difference could be 0. They could be equal. Which is what we said. The men and women could be the same. There's a chance of, so there does not appear to be a significant difference. There is not sufficient. There is not sufficient evidence to warrant rejection of the claim. Based on the results, does it appear the movement have equal success? Yeah. Which one is that? The comp B suggests that there is no. Confidence interval suggests that there is no significant difference. There it is. Does that make sense? So if 0 is in your confidence interval, there's a good chance those things are the same, whatever it is you're measuring. Because their difference is 0. There is no difference. If 0 is not in your interval, then it's not reasonable to assume that they couldn't be the same. It's very likely they're not the same. All right. Is that good? If you had enough?